Let's look first at the physiology of acute or so-called normal pain. The transmission and perception of pain is controlled by structures of both the peripheral and the central nervous systems. Injury to body tissue sets off a cascade of chemical reactions called the inflammatory reaction. This local tissue reaction is ultimately translated into an electrical signal carried by peripheral pain nerves called nociceptors. There are two primary types of nociceptors: A delta fibers and C fibers. Stimulation of A delta fibers evokes sharp, acute, well-localized pain. Stimulation of C fibers produces dull and achy pain. From peripheral sites, pain signals are transmitted by nociceptors to the dorsal horn of the spinal cord. Here they synapse with interneurons. That is, the pain signals are transferred from the nociceptors to interneurons. Cell axons in the dorsal horn give rise to spinothalamic and other ascending tracts that carry the signals upward from the spinal cord. Interneurons carry pain signals to the thalamus and midbrain, where they are then transmitted via neurons to the cortex, the frontal lobe, and the limbic system. The actions of the cortex, the frontal lobe, and the limbic system contribute to the overall perception of the pain and determine its texture and intensity, giving it emotional impact, linking it to memories, and ultimately giving it meaning. Chronic pain is more than just prolonged acute pain. As pain signals are repeatedly generated, neural pathways can undergo physiochemical changes, known as remodeling, that makes them hypersensitive to the pain signals and can make the signals more intense and difficult to localize. If chronic pain goes untreated, the pain signals eventually become embedded in the central nervous system, just like a painful memory. The central nervous system, in effect, learns to have pain. These signals become a distressing and disabling message, constantly signaling the patient about an injury that really belongs in the past.